Hi, my name is Jean-Jacques Debray, and I would like to give you a quick introduction about the SAM pattern. Just to give a little bit of context, the SAM pattern is a new pattern that is particularly well suited to help you build front-end architectures where network events from friends, players, wearables, IoT sensors, etc. Network events are just as prevalent as user events. So the way we've been writing that kind of code, for pretty much the last 30 years, has been based on events and callbacks. And over the years, people have seen a number of issues with that approach. This code doesn't allow you to group those handlers in meaningful components that could be reused across application. It often relies on global variables. And it requires that you manage subscriptions to events. There's also some issue with the fact that we manipulating the DOM directly in the event handler, and there's not a good separation of concern between the application logic and the component, the view logic. Most recently, when network events started to kind of creep up the architecture, a data consistency issue started to appear, because even though JavaScript is single-threaded, you can often be in the position where you're actually processing events in a concurrent manner, and therefore you have to be very careful as to when the updates to the data occur. So overall, this kind of code is hard to maintain, hard to debug, hard to hand off when developers leave a team and you need new developers to learn the code. So here comes the SAM pattern. The SAM pattern is trying to answer the question that the industry has started to work on in the last 3-4 years. And the first answer the industry came up is they took that code and they actually put just a class wrapper around it. That's a React component. Then that was for the event handlers, and then for the view, in order to keep kind of a nice separation of concern, they just created a kind of a change detection mechanism, and they rendered the view when data changes, when the state of the component changes. But that didn't work. Today, the recommendation for React is that you have to write stateless components, you have to differentiate between container components and kind of just traditional view components. The reality is that you cannot fragment the application state in individual components. That does not work. So the industry has been kind of moving towards a new paradigm, the functional reactive programming paradigm. And I believe there's an alternative to FRP, because FRP is not proven to be such a good solution yet. And that alternative is the SAM pattern. So the first principle of the SAM pattern, just like React, is like it's based on functional HTML. The view is a function of the model. If you're not using that paradigm, I would highly recommend that you look at it. The second principle of SAM is that the application state mutation is a first-class citizen of the programming model, unlike FRP, which is trying to ignore or hide or pretend there is no application state mutation. In SAM, application state mutation is a first-class citizen. So how does that work? Well, SAM is based on a formalism called TLA+, which was created by Dr. Lamport, a researcher at Microsoft. And this is kind of what it looks like. So let's take a very simple example, the simplest model. For each event, we would increment a counter. And most people will mutate the application state with a piece of code that would look like this. In reality, this is not exactly how application state mutation works. What you really need to do is to first create a proposal. The proposal will, of course, have the value of counter plus 1. And then you still cannot make a direct assignment of that proposal. What you need to do is you need to ask the model to accept the proposal. And then, only then, you'll be able to access the new application state, and that's what we call learners, where that can access that application state. So If we look at the overview of the pattern, the proposers are called actions. The acceptors, sometimes they could be more than one, are called the model. The model is a critical section. In other words, it can only process one action at a time. And then the learner are the state function. And the state function is a relatively new concept. Its role is to create the state representation and pass it on to the view to be rendered. It's also in charge of calculating if there's any next action that need to occur once you reach a particular application state. And that concept is fairly new. A lot of people have some questions. One of the nice aspects of it is that it clearly decouples the model from the view, which is not true of MV patterns in general. So let's look at some code. This is a little fishing game that's available on GitHub. You're going to draw a rectangle, and behind the rectangle there are a number of hidden fishes, and at the end of the game, when you release your mouse, it will count how many fishes you caught in the net. So the first element of the pattern is an action. Its role is to translate an event into a model proposal. And here what we see is that it's translating the event position into a new rectangle request. And the model will process that request as a unit of work. Nothing else will happen in the model, in the mutation of the application state, until that processing is complete and the state representation has computed, the state function has computed the state representation. At that point, the view is ready to display the state representation. The view is often structured in themes that are interchangeable. The theme components are 100% decoupled from the application logic. That's one of the nice outcomes of SAM. The last step of the pattern is to compute the next action. And in the case of one event, when you release the mouse, that's when we start counting the fishes. And in that case, we invoke the next action, which is select objects. The action is 100% reusable. As you can see, we pass some parameters that are relevant to our application, but the object itself, is just using a counter and a rectangle, an array of fishes and a rectangle to calculate how many objects it needs to select. So again, that sample is available on GitHub, like many others, and we're happy to answer any question you have about it. So if we could summarize the pattern, it could be summarized in just one line of code. That's what the pattern looks like. The view is a function of the model. The function is called the state function. It has one argument, the model, and the model changes. It exposes only one method. I call it present, and it changes when an event or intent is issued by the user or the network, and the action create a proposal that is presented to the model. Once the state has created the state representation, then the next action predicate computes if there's a new action, and it will invoke it if necessary. So I really want to emphasize that SAM is very simple. What you see is just a specific way of factoring your code. And here's a quote from Daniel Neveu, who's an entrepreneur and a full-stack developer, and he's really enthusiastic about this new pattern. He sees the concept to be very minimalist, but at the same time extremely powerful. So in conclusion, SAM's programming model is centered on mutation, not immutability. It is based on a single state tree, a true one. It doesn't have sagas or any kind of stateful components. It's focused on what are the actions that are allowed. It's not, focused on subscription. I really want to emphasize that the view components are 100% decoupled from the application, and one of its core principles is following React into using functional HTML and as opposed to templates. From an architecture perspective, SAM pattern is agnostic to any form of wiring. Simple Java functions work just fine. It's side effects friendly and implements new concepts such as action hangback and generic cancellation. the code of action, model, and state is truly isomorphic, and I've shown in many cases, in all cases, that this code can be moved to Node.js, for instance, without any difficulty as is, just by changing the wiring. Finally, you can also weave third-party actions that can present their proposal to the model, say using an OAuth token. If you have, and the SAM pattern can be implemented with the framework of your choice. We have examples of being produced by the community for pretty much every framework, including Angular 2, React, or if you don't want to use a framework, you can also use Vanilla.js. If you have any questions, you can go to the homepage of the pattern at sam.js.org or join us on Gitter. If you have any question, I'm sure a lot of people would want to answer them. Thank you.